Class 10th, chapter number 6, triangles. Problems based on the Pythagoras theorem, exercise 6.5. So let's do some problem of this exercise. So question number 6 is given, ABC is an equilateral triangle and side is given 2A. Find each of its altitude. Now for the solution, as given, ABC is an equilateral triangle, that meaning is all the three sides of equal to 2A. Then we draw the perpendicular AD on the side BC, as we have to find out the altitude. So AD is the height or perpendicular or altitude of the triangle ABC. Now by this altitude, triangle divided into two triangles. So we compare these two triangles, ADC and triangle ADB. In these two triangles, AC and AB, these two sides are equal, and angle ADB is equal to angle ADC. Both angles are equal to 90 degree, and this perpendicular, that is AD, is the side which is common for both the triangles. So we are having hypotenuse, right angle and side. By RHS congruency, triangle ACD is congruent to triangle ABD. As the triangles are congruent, then their corresponding parts are also equal. Then we can write CD is equal to BD. Now this meaning D is the midpoint of the side BC. Now D is the midpoint, so we can write BD is equal to half of BC. Now put the value of BC is 2A. So half of 2A, 2 and 2 will cancel out. So it will become BD is A. That is BD is equal to CD is equal to A. Now in the triangle ADC, which is the right angle at point D, in this triangle we use the Pythagoras theorem that says hypotenuse square is equal to perpendicular square plus base square. So in terms of the sides of this triangle ADC, we write AC square is equal to AD square plus CD square. So we have to find out the value of AD. So we get AD square is equal to AC square minus CD square. As this CD we have to transpose to the left hand side. Now put the values of these sides. AC is 2A square and CD is A square. So we get 4A square minus A square. So 4 minus 1, that is 3. So we get AD square is equal to 3A square. So squaring on both sides, we get AD is equal to under root 3A square and it is equal to A under root 3. So we can say altitude of the triangle is A under root 3 unit, and each altitude is same A under root 3 as each side of equilateral triangle is equal. So all altitudes are also equal to A under root 3 unit. Now the next question, question number 7. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the square of its diagonals. So we have given a rhombus ABCD where AC and BD are the diagonals and they are intersecting at point O. We have to prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. In mathematically, we can write AB square plus BC square plus CD square plus DA square is equal to BD square plus AC square. That is sum of all four sides, square of sum all four sides is equal to sum of square of its diagonals. So for proving, we know that ABCD is a rhombus and diagonals of rhombus bisect each other at right angle. So all these four triangles are right triangles and diagonals bisect, that is OD is equal to OB and OA is equal to OC. By the point O, both the diagonals divide into two equal parts, and also angle AOB is equal to angle BOC is equal to 90 degree, and that is all four angles at point O are equal to 90 degree. Now we take the right triangle AOB. In this right triangle AOB, by the Pythagoras theorem, we can write AB square is equal to OA square plus OB square. This is the equation number 1. Similarly, in the triangle BOC, we write BC square is equal to OB square plus OC square. So, in all four right triangles, we apply the Pythagoras theorem. So, in the triangle third, in the triangle COD, again we get CD square is equal to OC square plus OD square. Now last triangle AOD, in this triangle also we get AD square is equal to AO square plus OD square. That is, in all four right triangles we applied the Pythagoras theorem and get the four equations. Now adding these four equations, as these equations, the left hand side is four sides of the rhombus. So we are adding the equations 1 plus 2 plus 3 plus 4. That is AB square plus BC square plus CD square plus DA square is equal to OA square plus OB square plus OB square plus OC square plus OC square plus OD square plus OA square plus OD square. As it is, we are adding left hand side to the left hand side and right hand side to the right hand side. Now we are observing here all the terms OA, OB, OC and OD are 2 times here. So we get twice of all the terms OA square plus OB square plus OC square plus OD square. Now, since in previous slide we had written OA is equal to OC and OB is equal to OD. So, we can write in place of OC, we write OA. In place of OD, we write OB. So, we get OA square plus OB square plus OA square plus OB square, that is twice of OA square plus twice of OB square. Then OA, twice of OA, this can be written as OA only we are talking. So OA is the half of the side AC. So in place of OA, we can write half of AC. And similarly, in place of OB, we can write half of BD. So it is twice of 2 times of half AC whole square plus 2 times of half BD square. So in the next step, twice of this 2 and 1 2 will cancel out. So we get AC square upon 2. Here also 1 2 and 1 2 will cancel out. So BD square upon 2. Now in these two terms, we can take 1 by 2 common. So it will become 2 by 2 is into AC square plus BD square. Now 2 by 2, this also equal to 1. So we get AC square plus BD square. That meaning we are having here AB square plus BC square plus CD square plus DA square is equal to AC square plus BD square. And AC square plus BD square, this is the diagonals. So we proved that sum of the squares of the sides of a rhombus is equal to the sum of the square of its diagonals. So it's proved.